So this is normal stress. And then we are going to look at our shearing stress. Okay, so this is our shearing stress. So our shearing stress, we are going with 20, 40, 60. I decided to stop at 80 because the maximum shearing stress given is 80, right? So minus 20, minus 40, minus 60, minus 80. Okay, so this is what we have. And what we know, okay, what we know is that we have our normal stress of 90. So this is our stress X. This is our stress Z line. And then we have a shear of 60. We have another shear of 60. And I just mentioned that the rotation of element is clockwise. This is point X. This is point Z. Okay, then we were to just draw a straight line. Right. So from here, we are going to calculate what is going on. So center of circle. I better keep right a bit. So center of circle. And we are going to focus on XZ plane. Okay. So the stress average is equal to 90 plus 0 by 2. This is 45 megapascal. Okay. And then we're going to calculate tau max, the radius of circle. Okay. So again, for XZ plane, so our tau max for XZ is equal to 60 squared. Square root of 60 squared plus by 45 squared. Okay, so 60 squared, 45 squared, 75. Okay, so now we can we can construct our first most circle. So we know where the average of the circle is. Okay. This is our point O. Then we can construct our first circle. Our first circle, 75, and it's going to 150. Okay, so this is about the position of our first circle. Okay, so that's the position of first circle. So we know what we know, right? What we know is point Y. I'm going to highlight this point, okay? I'm going to highlight point Y. There are no shearing stress, okay? So there's only one line that shearing stress will be equal to 0, okay? And this is on this line that I'm highlighting in here. So point Y stress state has to be on this line, okay? Where is it? We have to meet the criteria of the tau max that is equal to what? 80 megapascal. Okay. So what are the two possibilities? Okay, two possibilities. So I'm going to have case number one. Okay, I'm going to have case number one. Okay, so case one. Okay, case number one is where stress A is equal to minus 30 megapascal. Now, why do I call it stress A and later B and C in 3D mole circle, right? 3D mole circle. The principal stresses are labeled as stress A, stress B, okay, stress B, and today I'm not right. Stress B and stress C, right? So case number one, okay, over here, this is going to be my minimum stress. Okay, so this is like our anchor. Okay, our anchor. And then we know to meet the condition, right? Maximum shearing stress we are given is equal to 80 megapascal. Okay, where we are when we calculate our XZ circle, we are only given at 70. Right? We are given that this is only 70. Right? So the exact plane did not generate the maximum shearing stress. It's only 75. Okay. So the conditions given to us, tau max for this 3D loading is 80 megapascal. So the first position of point Y is equal to minus 30 plus by twice of 80. Why twice? Because this is the radius, yes or no? To get the diameter is twice. So minus 30, so 160, minus 30 plus 160 is equal to 130. Okay. So now we are going to draw the 3D mole circle. Okay, now we're going to draw the 3D mole circle now. Okay. Remember, 3D mole circle has to have 3 circles, not 1. Okay. Again, the solution manual, I did not do the solution manual. Okay, I just post what is given to me by the publisher. So over here now, okay, is the next circle. And where I draw the next circle, this point over here, exactly over here, will be my stress Y. Why? Because if we were to look at the question, okay, if we were to look at this question, stress point Y has 0 shearing stress. Okay. So now we are good to go. Okay.
Eugene, may I ask a question?
Yes.
So, why at 120 was that not our Y?
It cannot be your Y because that belongs to your exact plane.
It can't touch?
It cannot. Okay. The 120 cannot be your Y because that belongs to the exact plane. That circle belongs to the exact plane.
So you can't have more than 2 points on a circle?
You can. I've shown you a situation that you can, but this case you can't. Okay, so remember last week I did this example, right? Over here you can see what? 3 points X, Y, and Z are on the same circle. But this answer is not valid because it did not meet the maximum shear stress condition.
Okay.
So if let's say if this question, right, this question did not say that the maximum shearing stress has to meet 80 megapascal, yeah, then it is possible that 120 is the value for stress Y, and minus 30 is your stress Y value. Alex?
Okay.
Okay, but for this case, we have to meet the condition.
Okay.
Okay, that is the
One
reason.
other question.
Yes.
We talked about how it's very common that our stress is typically twice the max shear.
Yes, our yield strength.
Yes. So that doesn't apply to every question. Like even if you were to apply it here, you'd still be within your box. So it would not matter. Do you know what I'm saying?
So the maximum shear stress is 80 megapascal.
Yeah.
So the normal stress limit is plus or minus 160.
Right.
So what you say is correct.
But it's not fair to assume that. Like we could get into trouble if we always assume that.
No, you will not get into trouble when you always assume that.
Okay.
It's the best thing to assume.
Okay.
Okay, so that's known as the maximum shear stress criteria.
Okay.
Okay. Right.
Thank you.
So now if I were to draw the next circle is here. Okay. Right. So you have now you got 3 circles, 1, 2, and 3. Okay. So let's do the other one. Okay. Let's do the other position. So if now we were to do let me I think Microsoft is coming up with a new thing. It's doing a setting for me that I don't like, but anyway. So let's do another Y value. Okay, so I'm going to copy this circle. Okay, and then I'm going to paste it here. I'm trying to do a paste now. I think I'm good now. So I'm going to wipe everything off except the circle. So now we are given another situation. Okay, we are given now case number 2. Okay, now I have case number 2. Where I want my stress A to be at 120 megapascal. Okay, so that is my so stress A has to be at 120 megapascal, right? So now I need to somehow get rid of this wording down here. Okay, I'm going to move this now. Now I'm going to, if I were to zoom out, okay. So what I just did, or what we are just going to do, is now we shift the anchor. Now this point over here is going to be our anchor now. Okay. And then you just move the circle. Now this circle is, remember, this circle is at at maximum normal stress at shearing stress at 80 megapascal. Okay. So I'm going to get this down. We are good. Okay. So now over here, this is our Y2. Okay. And then I'll put in our circle. That is our the othermost circle. Okay. So for that value over there, this will be equal Y2 will be equal to 120 minus twice of 80. Okay, so it's equal to minus 40 megapascal.